This video, we're going to talk about finding absolute extrema on a closed interval. This is from section 3.2. Let's go ahead and get started with number 21. And f of x is equal to 5 minus 2x squared on the interval from -3 to 1. We're going to find the critical numbers. F prime of x is -4x. Set that equal to 0. X is equal to 0. And I'm going to make a table of values here. F of x, that includes the endpoints, -3, 0, and 1. My endpoints and my critical numbers. We're going to stick them in and calculate their y values. So 5 minus 18 is a -13. 5 minus 0 is 5. And 5 minus 2 is 3. My conclusion is that this is the absolute min because it's the lowest of them. And this is the absolute max because it's the highest of them. So we have, let's see here, 21. Our absolute minimum is at -3, -13. Our absolute maximum is at 0, 5. Let's look now at number 23. F of x is equal to x cubed minus 6x squared on the interval from 0 to 6. F prime of x is equal to 3x squared minus 12x, which is equal to 3x times x minus 4. We're going to set that equal to 0. 3x equals 0, or x minus 4 equals 0, x equals 0, or x equals 4. 0 is not only a critical number, but it's also an endpoint. I don't have to list it twice. 0, 4, and 6. When I put everything together, f of 0 is 0. 64 minus 6 times 16. Let's do it this way. So x squared times x minus 6. So that's 16 times a -2 is a -32. And 6 minus 6 is 0. So we have ask your teacher how they want you to answer this. If you have two that are tied like this, sometimes your teacher will say that there's no absolute maximum because maximum is singular, but the book is going to answer this that there are maxima, the plural of that, at 0, 0, and 6, 0, and there's minimum. There's a minimum at, and these are absolute. At 4, -32. So we'll go with how the book answers the question. Again, remember that minimum and maximum with the at the end are singular. Maximum, maxima, or minima with ma at the end are plural. It comes from Latin. There's lots of other words that end in UM or US or things like that that get like alumnus, alumni, like that, right? But if it's feminine, like alumna, anyways, alum and alum, you can say alumna, but let's look at number 27. G of t is 4 times 1 plus 1 over x plus 1 over x squared on the interval from -4 to 5. So that makes g prime of t equal to 4 times 0 minus 1 over x squared minus 2 over x cubed equals to 0. So I'm going to have to make a common denominator here. That's going to be a negative x minus 2 over x cubed. And negative x minus 2 equals 0. I'm really not interested about x being equal to 0 because it's not in the domain of the original, even though it's within this interval. So negative x is equal to 2, x is equal to negative 2. We have x is negative 4 is negative 2 and 5. And g, these are t values, not x values. That's interesting. That's a misprint in the problem. If this is supposed to be t values, then these should be t values here. Your variable should match. So either this needs to be x or that those need to be t's. I assume those are supposed to be t's. So let's see, 1 minus a fourth plus a 16th is 16 minus 4 plus 1 over 16 is 13 over 16. Negative 2 is there was 4 times this. So that's actually 13 over 4. Then g of negative 2 is 4 times 1 minus a half plus a quarter is 4 minus 2 plus 1. 2 plus 1 is 3. And g of 5 is 4 times 1 plus a fifth plus a 25th is going to be 4 times 1.24 is 4.96. This is 3.25. I'm doing the wrong problem. This is 28. I'll go back and do 27 in just a second. But so that means that my absolute min is at -2, 3. My absolute max is at 5, 4.96. Let me go back and do number 27 now. Number 27 is actually, again, we have a typo here that says G of T and it's got X's in the book. So I'm switching the X's to T's. And this is going to be G prime of T is -1 over T squared plus 4 over T to the third. So that's a -T plus 4 over T to the third. And when I set that equal to 0, then I have -T plus 4 equals 0, -T equals -4, and T equals 4. T equals 4 is outside of my interval of -2 to 1, so I'm not interested in it. T, G of T, -2 and 1. When I stick in -2, that's -1/2 minus 2/4 is another 1/2, so that's a -1. When I stick in 1, 1 minus 2 is a -1, and so I have absolute maxima at -2, -1, and 1, -1, and no absolute minima. How do I know that that is a maximum and not a minimum? Let's pick any other point that is in between my endpoints, like -1, and see if it's higher or lower. So if I were to pick G of -1, that'd be a -1 minus 2 is a -3, which is lower here. So I could also find what's going on at with that vertical asymptote there at 0. If I did the first derivative test, I'd see what was going on. Here's 0, and here's 4 is somewhere over here. I'm only interested in the interval of -2 to 1 in my first derivative test. So pick something in here, -1, like I said, and stick it in. 1 plus 4 is 5 over -1. That's negative. And then 0 to 1, so something like a half. It's a positive number over a positive number is a positive number. So it's increasing, but it's not going to, it's going down and coming back up. It starts off at -2, -1, goes down and becomes, it's undefined at 0. So it's going down like this, and then it's coming up from 0 and back up towards -2, -1. We have 1, -1. and there at the same value there. Okay. That was 27. Let's finish up this video with number 29. Then we'll come back and talk about some application problems next time. So 29 says h of t is equal to t minus 1 to the 2/3 power, or on the closed interval from -7 to 2. So h prime of t is equal to 2/3 t minus 1 to the -1/3 power is equal to 2/3 t minus 1 to the 1/3. H prime of t is undefined at t equals 1. There's a cusp there because that's in the original domain. So we have t, h of t of -7, 1, 2, -8, 2/3. So cube root of -8 is -2. -2 squared is 4. 1 minus 1 is 0. 1 to the 2/3 is 1. So we have a absolute min at 1, 0. We have an absolute max at -7, 4. That'll be it for this video. We'll come back, like I said, next time and do a few different application problems for these extreme values, extrema, both relative extrema and absolute extrema. So see you for the next video.